it says Wi-Fi not working. What we want to do is we want to restart the machine, hold down the Alt key, and then see if we can get options on get Wi-Fi availability. So here we want to see if we have any option for network, and as you can see, we have nothing there. There's no Wi-Fi. Um, okay, let's take the back cover out. Uh, we are not going to replace the Wi-Fi card because this is coming from a repair company. Uh, they must have replaced the Wi-Fi card first, so we are not going to do that. What we will be doing is we will directly go and take the board out to find out exactly what is happening. However, just to sometimes they are so busy they may not really get time to do it. So what we should, I think, what we should do is let's put in another Wi-Fi card and see if that will solve our problem. So disconnect our charger, the battery. Let's put in another Wi-Fi card and see if that will solve our problem. Okay, let's check with this one. Let's try again. Hold the Alt key. We don't have to put the machine to desktop because we don't really need to be at the desktop level. We just want to see, um, we just want to get network, the available networks present. So we don't necessarily have to put the machine to desktop because that's going to take too much of our time. See, and we say we still do not have anything on our network list. So it's definitely not the Wi-Fi card. Like I said, I am also very sure that they have also tried a different Wi-Fi card before sending the machine here. If it was a Wi-Fi card issue, it wouldn't be here. That I can I can guarantee you guys. But sometimes you may find 1 out of 100 in a case where they probably didn't try it out because they were very busy, or they tried it out with a faulty Wi-Fi card. But that's yeah. So let's quickly take the board out, get an idea of what's happening. This is the board number of this is going to be 80-00165, and this is going to be a 2015-2017 MacBook Air board. One of the ways we can easily confirm that it's the JTAG connector. So because the JTAG is small, that will tell us that uh, this is a 2015-2017 board. So let's quickly take our board out to get an idea of what's happening. Now that we know we have no Wi-Fi signal, so our focus is going to be on the Wi-Fi circuitry. Okay, board is out. Let's put the shell on the side. Let's open up the board view. So this is a 2017 board. That's because it's a 1.8. So usually if it's a 1.8, that's 2017. If it's a 1.6, then that is a 2015. So let's open up our board view and go to the section of 80.00165. Yeah, that's it. Okay, so this is the Wi-Fi connector, which is okay. This, the Wi-Fi connector is J3501. Let us open up the schematic, give you guys an idea of what we'll be doing. Okay, so let's go to that. Let's go to that connector, which is J3501. We search for J3501. So here it says wireless connector. It says wireless connector. So this is the connector here. So we have now what we want to do now is we want to see what voltages we have here. First of all, we need to understand what voltages is required for our connector to work. So we want to see if those voltages are present. So the first one we want to start with is the 3.3 volt underscore. So PP3V3 underscore WLAN. So we want to check to see if that voltage is present. And obviously if that is not present, and then we then work our way through. So this is where our focus is going to be. This is where we will be basically placing our focus on. So let's get a DC jack, connect charger to our board. Okay, our board is starting. So the next thing we want to do is we want to copy this signal here and then paste it on our our board view. And then we want to see if that's want to see if that is present on our board. So we flip to the other side of the board. So arrow, we can measure that at arrow 5470. Let's locate that. Arrow 5470 is going to be this guy here. That's going to be our 5470. So let us see what we have. Do we have 3.3 volts there? We're supposed to have 3.3 volts. Let's see if we have 3.3 volts. And we have 0 volt. So I'm not sure if you guys can see that. So that is 0 volt. You're supposed to have 3.3 volts there. We have 0 volt. And I'm just going to go back. So now we do not have, so what that means is we don't have power going to the connector. So if we don't have power going to the connector, it is the same that the machine will not detect the presence of the Wi-Fi card. So we don't have power here. If we don't have power here, it means this connector will not be powered. If the connector is not powered, you will not have the Wi-Fi or Bluetooth function. So what we now want to do is we want to see how PP3V3 is being created. So we now need to go to U3550. So here it says, if we see here, it says 3.3 volt W wireline switch. So this is where 3.3 volt is being created, and the component, the chip that does that, it's a U3550. Now, how is this going to work? So you see, this is a very simple circuitry here. You have V in, you have V out, you have on, and then you have ground. Now, what does that mean? So in order for you to have output, which is the 3.3 volt, which we are currently missing, we need to have input, which is 3.3 volt in S5 state, and definitely that will be present. So what we need in order for us to have outputs are going to be two. First, we need voltage at A2, B2. We need voltage here, and then we need to have an enable signal for it. So the enable signal is what you will find, the one that says on. So that is the signal that will tell the chip to basically to output 3.3 volt. Now that signal is going to come through our SMC, and it's gonna be SMC underscore Wi-Fi underscore power underscore EN, which is enabled. So this is going to be the enable signal. So we are expected to have two signals uh, at U3550. So first thing we want to do is we want to see if we have um, voltages at A2 and B2. So let's go to U3550. Let's go to our board and then search for U3550. We search for U3550. U3550. Okay, so this is U3550. Now, what we now want to do is we want to see if we have 3.3. So let's see what we have on pin 4 are the same thing. Let's see if we have voltages at our pin 2 and pin 4. Let's locate our U3550 on the board. So that's going to be this guy here. This is our U3550. So now let's see, do we have PP3V3 on the board? With that, we are 100% sure that we will be having that. So let's see. By the way, this board is liquid damage because I'm seeing that and then that. Hmm. Okay. So let's see what we have. Let's confirm PP3V3 that you can confirm at this cap here. And yes, we do have it. The next thing we want to check is we want to see if we have an enable signal to the chip. So if we have an enable signal to the chip, the next thing okay, first let's see if we have an enable signal to the chip. The enable signal is going to come from the SMC. We can measure that here. So we can measure for the enable signal here. At this TP at this track point here, let's see what we have. And we have 0.9 volts. So that is why we do not have the output. So as we are supposed to have 3 point something volt at the enable signal here, but we have 0 volt. So that is why we do not have. That is why our Wi-Fi is not. So basically, what is happening is this the voltage here is present. However, the enable signal is not present, and then the enable signal comes from the SMC. Let's now find out why we do not have that signal. So that's the way that signal is going to be generated. So if we come here in order to see where that signal is coming from, so what we do is we copy, let's do this. So we copy here, we copy this signal and paste it on our, we copy and then paste it on our search. That will give us an idea where the signal is coming from. So here it says in. This is where it's going into a chip. We are not interested in where we are not interested in the signal going into. We want to see where it's being generated from. Now, so usually because the start of it is SMC and then Wi-Fi and then power and then EN, it means the source of it is going to be SMC. So let's search. See. Here it's also where it's going into something. We don't want to see, we don't want where it's going, we want to see where it's being generated from. So here it's where it says out. Here it says out. Now this is where we want to come to, and that is where that is our U5000, which is the SMC. So if we come to, so this is one of the signals that comes out from the SMC. Okay, so what we want to do now is let us basically take a look at our SMC and find out why we do not have. Okay, so we have a bit of a corrosion around here. So that's going to be on this caps here. That's may just be an indication that there might be a bit of a liquid underneath the SMC. So what we're going to do is The PP3, those caps are C508, C5008, and C5007. So it's C5002 and C5007. So those may just be an indication that there might be liquid underneath the SMC. So what you want to do first thing is we will be replacing those two, although those are not our problem, but just for future references, because when those caps fail, there will be a short on your PP3 before two, and then the device is not going to start. So what we will do, we'll replace that for future, just as a preventive measure. But right now, we want to reflow our SMC and see if we will get our signal to be generated. So first thing we want to do is to reflow the SMC. If that doesn't solve the problem, then we will have to replace the SMC. First, we'll give it a slight reflow in order for us to remove the edge bonding. Let's remove the edge bonding. Okay. Now let's reflow the SMC. Okay, while we're here, we can as well. Okay, now it's okay. The SMC moved. Let's just since it moved, let's see if we have. Let's lift it up and see if we have any type of corrosion underneath the SMC. Or we can just leave it. I mean, yeah, let's leave it. If it doesn't work, we can always replace it. So now let's just replace the two caps that are not looking good. Okay, you see one of the part is actually gone, and that is C502. That is actually off. But like I said, we don't have a problem with this cap now, but should it fail in future, it will create a short on that line, and it will have a short on the PPP before too, and the machine is not going to start. Okay. Let's replace the two caps. Okay. So while we are waiting for the SMC to cool off, so let's see, this section of the board is also corroded. We need to replace that cap, so that's going to fail. And also we have corrosion here as well. That is not an immediate issue that we have in now, but that may be a problem in future. So while we're here, let's just replace those. Okay. Okay, let's put back these components. And then the cap, which is this one here. So we need to set that. It's not sitting as we want it to. Okay. So that's so what we have just replaced. It's by the section of Q8150, we have replaced R8153 and also R8152. R8156 doesn't seem to be on the board. Uh, let's see. It's 5 and then that. Okay. Okay. Let's not worry about that for now. We may not, because I see the pad of that is also off the board. Let's see what we can. Okay. Let's test our board to see if we have a working board at least. Yeah, before we do that, let's make sure we don't have a short on our PP3B42 because the SMC moved while we were busy with it. See if it's not shorted. Okay, it's not shorted. Let's see if we have a working board. No fan spin. Okay, so that SMC has to. We have to obviously replace that SMC. We have to redo the process. So I'm very sure SMC is PPDC in. It's present. PP42. SMC is going to be 8.2, 8.3. Yeah, yeah. So SMC is not running. Let's redo the SMC again. So this time, let's just take off the SMC. Uh, okay. So we are going to manually reboot the SMC. The way we do that is going to be easy. So let's second. Second? No, no, no. Okay, so the next thing we want to do is we want to see if we can manually gain evenness on the balls. So press down and then move it. Okay, that's okay. Let's take it out. Save any of the ball. Yeah, let's redo that. Okay, now let's clean the SMC and now we can install it. While you are installing the SMC, be aware of its orientation. Okay, so now let's put the SMC back. Peter, can I have the watch, please? No, it's fine. Just it's fine. Okay, let's give it a bit of time to cool off, and then we can. While we're waiting for that, we can clean this section of the board. Be very sure that you can see what you are. Yeah, it's important, eh? Because you don't want to just place you're not seeing anything. At all times, you need to be sure that you can actually see what you are trying to capture. Sorry. Okay. let's check our SMC now. I like to disconnect my fan while checking. But before we plug our charger, let's confirm we don't have a short in our PP3B42. Okay, we don't have a short. Let's see what we have. PP bus. Do we have? It's PP bus 8.2, 8 or 8.56. So let's see. PPDC in 16.4, PP3B42, 3.4, PP bus, and just put it to the out. 8.5. That's fine. That's really good. So let's see. Do we have SO rail present? Let's confirm that. Now we can check at L7520. That's this inductor here. This guy here. And that's it. Okay, we have a starting machine. Now we can connect our fan. Okay, let's okay, our board is starting. Now what we want to do now, we want to go to our um R5470. We want to see if we now have our 3.3 volt for our wireless for our wireless. So if we don't have it, then we may have to replace the SMC. Let's see, do you have 3.3 volt now? And there you have it. We have 3.3 volt now. So that means we now have a working Wi-Fi. So what you want to do is you want to clean that section of the board first, and then we can test it, and we should have a working Wi-Fi. Okay, so the next thing we want to do is we want to see if we have working Wi-Fi. Let's just quickly like this. Okay, we are only going to connect the cables we require for the testing. We're not going to connect all of the cables. That is going to be done while the machine is being assembled. Right now, we only connect the cables we need to see if we have a working Wi-Fi. We don't need the Wi-Fi. We don't need the webcam cable connected, but just so that the cable just don't go. We don't want to have it loosed. That's the only reason why we're connecting it. Okay, so let's see what we have. Let's connect our charger and the OTK. Okay, our fan is spinning. Let's wait for Apple logo. We're holding down the OK. So we have image. So the next thing we want to see if we have available networks. And that's it. So you guys can see now we have available networks. Before now, when you click, you were having nothing on the available networks. Now you can connect to your Wi-Fi and J5 5I M 3AG. So there you go. Now you have Wi-Fi. So that's about it. Thank you guys. I will see you guys in the next one. So a summary of what we did. So basically, um, we we had a machine that Wi-Fi was not working. The first thing we had to do was to replace the Wi-Fi card. This is coming from a repair company, so we were very certain that they might have done that before. So we tested the Wi-Fi card, and then we just had to do it again, and the Wi-Fi was fine. The Wi-Fi card was not the issue, so we had to take the board out. So the first thing we had to do was to go to we had to go to the connector, which is the holder for the Wi-Fi card, which is J3503. Now we went to our schematic to get a better idea of what is a J3503. Uh, so J3503, that is the connector for our wireless. That is basically our wireless connector. That is the connector that holds. That's basically where your card for your Wi-Fi as well as your Bluetooth is connected to the machine. So the first thing we had to do when we got here was to basically follow the power rails, which is the working condition of that section of that section of the board. And the first rail we checked for was PB3V3 underscore WLAN, which is a wireline. That rail was not present. We narrowed that down. We changed that down to UF3550. That is the chip that outputs that rail. And then what we had to, the two things we needed to confirm was the power to the chip and the enable signal to the chip, which is going to come from the SMC. And one of the we say that because it starts with SMC underscore Wi-Fi underscore power underscore EN, That tells us that the source of this is going to be the SMC, which is the starting of which is what's going to be the starting. And here it says in. So we had pp3 we had pp3 v3 present, but we had zero point 0.9 volt on the enable signal. So we then chased that to the SMC. We found a bit of a corrosion around the SMC. We did a reflow that didn't work out exactly, so we had to remove the SMC, redo it, and then we had to put the SMC back. And afterwards we have our PP3 V3 enable signal present on U3550, and now we have a working Wi-Fi. Thank you guys. I'll see you guys in the next one.